everyone. Today we have our another new episode and we have very interesting topic, life of the sun, and we have our all famous, world famous speakers, Professor Edward, Professor David Smith, Professor Ching, and Professor Paul. Thank you for joining today's. I want to start from Professor Edward.
Oh, hi. Thanks for this is kind of a curious topic. The life of the sun. Well, it was probably came into being about 5 billion years ago, and it produced planets. And in 4.5 to 5 billion years from now, the sun is going to go nova and incinerate the Earth. At the end. Now, there's more. There's more I can say, obviously, about the sun than that. And I'll make a couple of points. By the way, for those of you who are concerned about, well, couldn't we go off onto Mars or Jupiter or one of the moons of Jupiter and set a civilization up there, which we're going to probably do anyway. And then when the sun goes nova, well, we'll be out there, but it would still affect the climate and the the ecology of any planet in the solar system. So it's not that easy. But I want to make two kind of interesting points about the sun. The first is this. For those of your listeners who are concerned and are serious about climate issues, there's a lot of research that's been done, including by a 95, he just passed away at the age of 95, an old friend of mine, Fred Singer. Fred Singer did his doctoral committee included Robert Oppenheimer and Niels Bohr, and those of you who have heard those names, Niels Bohr came up with the current atomic theory. So Fred Singer was not some, sort of low-level, uneducated individual. He's done a lot of work before he passed away on sun cycles. And he had one of his books, which I'll hold up, I printed out his larger version so you can see, Unstoppable Global Warming Every 1,500 Years. And there are other scientists who I know who've looked at solar cycles. Most of us know that every 11 years the sun goes through a particular cycle. And this affects, obviously, radiation, climate, and things like that. Fred Singer and some of the others have looked closer at the sun to see how does the process going on in the sun affect our climate? Because it does. And to what extent does it? To what extent does, for example, extra carbon dioxide in the atmosphere affect climate as opposed to sun cycles? And how do they interact and so forth? So for those of you who are really interested in this topic, since we're talking about the sun today, you might want to take a look at some of the research. Unfortunately, a lot of this research is just ignored because there's kind of a narrative out there. We know what causes global warming, and so we don't have to look at anything else. But there are a lot of factors involved. And so for those of you who are interested, and since we're talking about the sun, take a look at some of the research done on sun cycles and sun weather. Literally, I've got a friend of mine who used to work at NASA who's basically a weatherman for the sun. He looks at what happens out in space with solar radiation. So that's the first thing I'll say. The second thing I'll say is, since we're talking about the sun blowing up or going nova in 4.5 or 5 billion years, think about humanity. Humans in the current form have been around for probably 200,000 years, maybe 150,000. You can pick your date on that. That's a very short period of time in terms of evolution. And so with the advances we've seen, and people like here we go, Ray Kurzweil, basically talking about the singularity. Our species is not going to be the same species probably 100 years from now, certainly not 1,000 years from now, certainly not 10,000 years from now. We're going to be a completely different species. And so when you think about the life of the sun and where we're going to be in the solar system, it's going to be very different. So it's hard to speculate. So that's kind of my interesting way of framing a discussion of the life cycle of the sun. I originally majored in physics and astronomy, if you can't figure out from my wall.
Yeah.
And so
Excellent.
It's a very interesting topic.
Excellent. Yeah, I can remember my dean when I was undergraduate students. My dean was one of the famous Professor Habib. He died already, but he always teach me that if you want to be really scholars, you have to do research on sun, stars, galaxy. It will help you to develop your knowledge. Always, always he inspired me. So that's why today I bring this topic, and I know all of you are expert on this field. Professor David Smith, what you want to add for today's discussion?
Well, what I love from your comment just then, Sharif, is studying the sun, studying the planet and the other universes gives us a sense of large scale. Versus when we come back and look at semiconductors and nanomaterials and stuff, we get the sense of small scale. But what really fascinates me is those two go hand in hand. Because what we see in the large scale, looking at the sun and the solar systems, is that small forces can have a big impact. And that's what we see also on the other side when we're down looking at the areas of the very small scale. And so it really gives us a place to do a boundary of understanding the extremes and the forces, which helps us create and innovate in everyday life. Now, I love some of the background that Edward gave on the sun and its age and stuff. It's also kind of interesting to me that it's the sun is 93 million miles on average from the Earth, and without the sun's energy life, we wouldn't exist here. So even with the fact that it's having a life cycle, we wouldn't be here without it sitting there. And what took me a while to understand, and I love some of my university professors on this one, is that from our perspective on the Earth, the sun doesn't orbit. The planets orbit the sun. But in reality, the sun orbits the center of the Milky Way, but it orbits it about every 230 million Earth years. So again, the sun helps us really understand a sense of scale, a sense of placement, and a sense of attraction and repulsance going there. And you begin to see the other things is that, if I look at the temperature on the sun, wow, it's pretty hot. But then you begin to go inside the core where you see the thermonuclear, the fusion reactors. It's even hotter there. And it's, when we look though at the Earth's sun, it's only an average size sun. There have been suns found which are up to 100 times larger. And many solar systems we found in our exploration have more than one sun. So in some ways we look at that and see how the forces came together to make us where we are here. Now I was talking about the core of the sun. It tops 27 million degrees Fahrenheit. Oh, I guess since we're talking international, that's 15 million degrees Kelvin. And it's pretty out there, and you begin to see it, but it is the source of the energy is that you can see it and begin to use through it. If you look at some of the deep space research at some of the other centers, you'll see that some of the suns actually have rings around them. And our sun in its early life actually had rings around it. And there is still some fine dust rings from the creation of the sun still around the sun. So you see the elements like that. What I am fascinated by today is particularly countries like China are trying to create artificial suns. And if you follow their experiments, they have made a lot of progress and beginning to see that put in place. My hope is that we can take some of the derivative technologies from them trying to make the artificial sun and begin to use it in ways to address the energy situation on our planet. Even though it's not real popular, nuclear power is one of the cleanest powers we have out there today. And I personally believe we need to go back and, at least for the near term, reinstitute more nuclear power. But the place I really see the advances is when I was a student and a professor at the University of Texas. On the corner of our campus, we had one building which had, at that time, the largest tomac reactor that was built. And if I look at using a tomac reactor in fusion, the process of the sun that gives us life, that to me is going to be a great power source if we can get the science and the physics and the material science, and the processes to manage it. What is the other great thing when you look at how we can create our own power sources modeled after the sun is this week there was an announcement that there's an AI now that can be used to control fusion reactors. And I think that is going to be the next great step that's going to help us, because the time periods in that are moving very fast. And again, it's at small scale, and the forces, how they interact. So again, knowing the sun and its place, knowing the small micros, that's going to help us solve these green energy challenges that I believe we have. So the sun is a great thing to model as we're trying to look at our future life extensions. So Sharif, thank you.
Thank you, Professor. Thank you, Professor, for your excellent analysis. Professor Ching, can you unmute, please?
Okay, yeah, okay. Okay, my this is my doctoral thesis is in large amplitude stabilization of drift instability. Okay, drift instability is the universal instability. Plasma, they tried to confine plasma, but they couldn't. What caused the plasma to escape? You see, I was doing research on how it escaped. So this is my PhD. I study plasma physics and control fusion, and I never use it. So just giving back to, but the reason I didn't use it is I solved. You see, there were kinetic theory and fluid dynamics, magnetic fluid dynamics, two conflicting theory, and I'm the person who came out with a solution for plasma fluid. It's called generalized fluid description. Okay, after I got that, then my professor, Harold Grad, told me. Harold Grad is a student of Coulomb, Richard Coulomb, and Richard Coulomb is a student of David Hilbert. So these guys are the top mathematicians in the world. Okay, he approved my solution. So I got the solution for plasma physics. Then I say, okay, I can leave plasma physics to do post science. Okay, so it's kind of the process is here, but now I look back, I see that I should use my post science to see what I can contribute to today's world. Okay, and to see how much contribution I can make. Okay, when we talk about sun, we're talking about the packing fraction, which is you look at atomic scale and you look at their packing fraction. It's a curve, curve up. So on two ends of the atomic scale, you have fusion and fission. Fission means you have a large element, it becomes small element, so it comes down. Fusion also, you have small element, you fuse, then you also come down. Okay, the fusion neutron is 14 MeV. The fission neutron is 2 MeV. Okay, this talk about building tokamak is just early stage. Okay, it did not concern this 14 MeV neutron. Okay, you need a fission blanket to use those neutrons. So it's not that easy. See, people talk about this, but I'm an expert, and I know they are completely wrong on the theory. Okay. So, I'm sort of looking down on this entire, plasma physics. And so basically, this is what I see that the pole science can contribute. Now I'm the leader of pole science, so I say the first thing I'm thinking about is whether the sun is created or it's just there. We find it. Okay, can we create the sun? The answer is obviously yes, because we are creating small suns in the form of nuclear fusion. But most likely, probably, we search for a planet if we want to, you know, to 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 travel to a new place. And you see, this is, the first thing I would like all the astronomers to realize that they should use the generalized fluid description for describing the plasma inside the sun. Okay, second, they should, all these astronomers give very strange names for all the stars, like the sun is G2V. Okay, I like them to use universal permanent number and they use the universal permanent software to remember, so name all the planetary and the suns with integers, so we can all remember them. Okay, just for knowledge management, there will be billions or trillions of stars, and you cannot just use English. It's not a universal language. Also, this whole situation is very fuzzy, so it's definitely fuzzy logic should play a part. And another thing I really worry about all this astronomy is that when they do something, they should calculate the value. Okay. Many people criticize, should we be spending so much time on astronomy? Well, they should calculate. Some of the things will never affect us. For example, the solar storm will affect us. Okay, it comes every 350 years, and it will affect all the electronic instrument on Earth. Okay, we need to have somebody keep check on that. You see, and also the Earth circulating around the sun. Okay, people study the stability of the circulation. Well, how long can we be on track? Okay, some computer science calculate that we can be on track for at least 150 million years. Well, that kind of thing has value. Okay, some of the thing is not really. They should put some value on what they do. Okay, so they need to look into value theory. And finally, David mentioned this. In my opinion, also pole science believes that nature is entering DNA, not entering life. Okay, we want our life should put all our intelligence into DNA. Okay, it's a storage of intelligence, cumulative from infinite past. So this is logical life science. We need to put all this in perspective, not let the astronomer, also fusion people say this is unlimited energy. I know they don't even have a theoretical foundation for plasma physics. You see, so basically, and if Sharif, you want to write, anybody want to write a paper on the things I mentioned, you know, it's a good topic about astronomy. Okay, that's it.
Thank you. Definitely, we can work in the research projects. Actually, we are launching many good research projects next month. We are launching with India Rotary clubs. We are providing training 3,200 students. From there, eight students eight students will come with their idea in WT forum with you for open dialogue. As well as we are actually offering some good solution for water. Next month, 22, actually water day. So we are working with UNICEF, we are working with Indian government as well as the Rotary Club of India. So hopefully this kind of collaborations and your contribution can add more values for human lives. Professor Pause, there is a question from audience. She want to know, how does the sun affect our climate? You are climate change activist and yeah,
Can you hear me first of all?
yes,
Yeah, the sound is okay.
yes, yes.
Because okay, I just wonder. I'm having some issues with my iPhone here, but okay. So yeah, I'll get to the climate thing, but first of all, um, I did do some plasma physics myself in some undergraduate projects and graduate projects, etc. And I created plasma with a CO2 laser and measured different transient molecules that were formed and would only live for a few microseconds, and then they would react into something else. So, but the sun, of course, is a fascinating topic. Basically, from a physics point of view, it's just gravity is holding the sun together, and the fusion reactions are pushing the sun apart, and providing they're the fuel source. So when we talk about fusion reactions, it's just, starts at the very basic. The sun's basically burning hydrogen. So hydrogen plus hydrogen, it's fusing into helium, or hydrogen plus deuterium, or hydrogen plus tritium. And you can look at all the different isotopes, and then you start moving up, and these incredible temperatures then create more reactions, and you work your way up through the periodic table. So it's basically creating all the elements. When I was in first year chemistry, we all had to memorize the first 20 elements. So as you move up, hydrogen, helium, I'll see how many I get. Don't record me. Don't quote me on this. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, and so on. Okay, so it goes all the way up there. These elements are all being created in the sun, I believe up to about iron or something. And then there's other processes that create the other elements. So the sun, not only is it a source of energy and heat that's vital for life on all planets, but it generates the elements that exist today. It's all suns are like this, and eventually, when the sun runs out of fuel, gravity brought everything together after the Big Bang, if you like, all of these different things floating around, and they started coalescing into because of gravity, the mutual attraction between mass. And when we run out of the hydrogen, over time, the sun goes supernova. It expands depending on the mass. Not all suns do that, but some just contract. But there's a finite lifetime, but we're talking about billions of years as opposed to any time scale that humans that humans developed over and that we think of. So the sun puts out a so the sun temperature and the location of the sun, the distance of the sun from the earth, those sort of things determine the mean temperature on the planet. So if Earth didn't have an atmosphere, you can do the calculation for the Earth, heat in equals heat out. What is the equilibrium temperature for that to happen? And the answer is 255 Kelvin, or about minus 19 degrees Celsius. So if we had no atmosphere, the Earth would be minus 19 degrees Celsius, but it's about 14, 15 degrees Celsius, which is an increase of about 34 degrees Celsius, 33, 34 degrees Celsius over what the black body calculation gives you with no atmosphere. So our atmosphere and our greenhouse gas effect effectively raises the temperature on the surface of the Earth to that comfortable mean temperature of 14 or 15 degrees Celsius. Now, of course, because we're taking all this carbon out of the ground and we're putting into the Earth atmosphere system, CO2 in the atmosphere, very powerful greenhouse gas, and methane and water vapor also. We've changed the chemistry of the atmosphere and oceans by increasing these these gases that are active in the infrared. They trap heat, and as a result, our mean average temperature is rising, and there's a lot of course, what's really bad for us is the distribution of the temperature rise on the Earth. The poles are rising much, much faster than the rest of the equator, so the jet stream gets disrupted. So we're getting all of these extreme weather events that are wreaking havoc around the world. So, what's interesting is that a lot of the satellites that study the sun, solar satellites, they have instrumentation and filters, so they measure the different radiation coming from the sun at all the different wavelengths and so on. And most of these satellites are stationed at a point between the Earth and the sun, where the gravitational attraction of the sun and the Earth effectively cancel each other out at that point. So it's considered like a quasi-stable point, or gravitational well, if you like. It's called the Lagrange L1 point. It's about 1.5 million miles from the Earth, and we put solar satellites there because it's a good place to put them. We don't need to expend much rocket fuel to keep them there. It's an unstable, a quasi-stable gravity point. There's actually 5 Lagrange points, L1 to L5, but L1 is directly between the Earth and the sun. And the reason I'm mentioning this point is because we all know about solar eclipses, where the Earth moves between the sun, where the moon rather moves between the Earth and the sun, and temporarily blocks out the sun, and there's a temporary there'd be a temporary loss of heating, at that particular point on the Earth. So imagine if we put something which you can read about and find out about. These ideas have been around for a while, something called a solar shade, if you like. So if we put some type of lenses or some type of reflector, coat mylar sheets with aluminum and somehow get them to this L1 Lagrange point, we could block some sunlight. If we were able to block 1 or 2% of the incoming sunlight to the Earth, we could dial back the system and go back to the temperatures that we had in 1750, before the beginning of the Industrial Revolution. So we're talking about just a couple percent of the incoming sunlight, and we could cool the planet back to where we were before. So that's just an interesting. I did a video just a couple of days about it. Can we use sunshades to block a little bit of sunlight? Because it doesn't seem like we're doing anything on the Earth. We continue to fund subsidized fossil fuels at the tune of $11 million per hour or something like that. Fossil fuel subsidies are the multi-billions of dollars, and we're subsidizing pulling carbon out of the ground, burning it, and continuing to change the chemistry of the atmosphere and ocean. So now we do get coronal mass ejection sometimes, or these solar storms. And in fact, there was a very minor one just in the news last week. Elon Musk sent up the satellites on one of his rockets. I think it was a Falcon 9 or Falcon Heavy or something. He sent up these satellites for this to provide internet from space. He's putting many satellites around the Earth, and there was some sort of small solar disturbance or storm that heated up the atmosphere. It caused the atmosphere to extend out further from the Earth than it normally would, and that put a lot of particles near where these satellites were. So these satellites, instead of being boosted to their proper orbit, they encountered a lot more friction than was expected, and they didn't have enough fuel to overcome the friction, so they didn't go into orbit. They plummeted back to Earth. So he lost about 40 satellites just last week, and that was a direct result of a small solar storm. Also, the Earth reflects about 31% of all the incoming sunlight. So, this solar shade would actually reduce small fraction of sunlight to cool the earth. Some people, there's other ideas about brightening the clouds, for example, to reflect more sunlight, marine cloud brightening. There's some ideas about called mirror, which is putting mirrors on the surface of the earth to reflect a bit of sunlight, because actually the albedo or reflectivity of the earth is actually getting slightly darker over time. And we can measure, we have instrumentation on satellites called CERES, CERES instrumentation, which measures the amount of, it measures these things. It's instrumentation on a satellite in orbit, and it measures the energy balance of energy, light going in and energy coming out. And it's determined it, and there's some interesting experiments where one of these solar observatories is in California. They also have a little device which measures what we call earth shine. So when we see the moon, because we see the sunlight reflected off of the moon, but some of the sunlight hits the earth, it reflects off of the earth, hits the moon, and then it reflects back to our eyes or sensors on the earth. So this is earth shine. And of course, the amount of earth shine depends on the albedo of the earth overall, or the amount of sunlight being reflected from the earth. So we have some devices to measure this earth shine in California. We've got about 30 years of data or something on this. And what the data is showing is that the earth is becoming darker. Okay, the earth is becoming, the albedo is actually increasing slightly, and that's enough to cause more absorption on the earth, and as a contributor to climate change as well. So there's some very interesting, and a lot of that is due to, well, there's two main mechanisms. Depending on the orientation of the earth and the sun and the geometry, where the earth shine measurements are measuring the reflectivity of not the whole earth, of course, but just certain parts of the earth. So sometimes it's measuring reflectivity mostly over the Pacific, and at other times it's measuring reflectivity over land in Asia, for example. So what we're finding is that part of the reason for the slightly increased albedo or decreased albedo or darkening of the earth is that there's less clouds over the Pacific Ocean, low-level clouds reflecting sunlight. And one of the reasons we think for that is that there's less phytoplankton in the ocean because of the ocean warming, and these phytoplankton produce chemicals like dimethyl sulfide, et cetera, which act as cloud condensation nuclei. So if there's less cloud condensation nuclei, then there's fewer clouds, and then rather than the clouds reflecting sunlight, it's the water from the Pacific, and that's of course reflecting a lot less. Also, we know, that the Arctic is becoming much darker. Of course, the loss of sea ice and snow cover on the land in the Arctic means that either the water underneath is exposed in terms of the sea ice, or the land, the permafrost and tundra is exposed rather than having snow-covered ground. So the Arctic is getting darker. So therefore, it's absorbing a lot more solar radiation in the summers, and it's causing greatly accelerated heating. So all of these things are kind of connected. And the sun, of course, has a magnetic field which varies on a 22-year cycle. But every half of that cycle, it adjusts the numbers of sunspots.
Thank you, Professor.
And sunspots are actually cool areas on the surface of the sun. But when there's lots of sunspots, there's more energy from the sun. The variance of solar energy is about 0.5% or so between the solar cycle being, or between lots of sunspots and very few sunspots. So all of these things are very important to climate on the earth.
Thank you, sir. Thank you, sir. Actually, I want to give the Professor Edward time. Then I will come back to you, Professor.
Right. Yeah, I need to go in just a minute here.
Sorry, I'll come back to you, Professor Paul.
Yeah, a couple of quick points. By the way, if you look at the Energy Information Agency in the United States, the vast amount of subsidies go to wind and solar, not to fossil fuels. Okay. and again, I'm just asking the audience to take a look at it yourself. Do a little bit of research on this. I don't want to go back to the 1700s, by the way, because that's when we still were emerging from the little ice age. I don't necessarily think that's a good idea, but I want to go back to solar real quick here. And sort of the practical issues. And one indeed, as I was going to mention, Elon Musk put up, these satellites, and 40 of them got knocked out because of what Paul has just described. And so in the future, when you take a look at why looking at the sun is going to be important, that is going to be one of the big things, because we're talking about putting up more satellites. We're talking about putting up space stations and more space stations. We're talking about settlements on the moon. We're talking about journeys to Mars that will take 6 months, and there's going to be exposure to solar radiation. So solar science is going to be very important in the future, because there's a practical reason. If we're just on the Earth, maybe it knocks out some communications occasionally or something like that, and we get nice aurora borealises. That's all nice too, but if we're a spacefaring civilization, space weather is going to be very important. So we're going to need a lot of advances in that particular area. By the way, climate is an issue, but again, what I would suggest is that we take a look at, again, some of the solar cycles and look in the long term about how they have affected climate and how they interact with some of these things we're talking about, whether it's carbon dioxide, whether it's oxygen, and so forth. And again, I'm just saying to your audience, do the research. And that's why it's so important to look at the sun, because it is becoming much more important to us, not only for climate, but again, as a spacefaring civilization. So anyway, thanks for a really interesting discussion. Sharif picks the most interesting topics. I think we can all agree on that. And I have to sign off. So thank you very much.
Thank you. Thank you. Thank you, Professor Edward. Sorry, Professor Paul. Yes. Professor Paul. Yeah. Yes, you can continue, Professor
go
Paul.
on.
Okay. Sorry, actually, I have to give floor Professor Edward, because he said that he has a meeting. He has to leave early. That is the reason. Professor David Smith, there are more questions from audience. Audience to know, like, how does the sun affect communications? Onika Shams.
Well, one of the prime places where the sun affects communications is where there's sunspots, particularly the very large ones, and they release very huge electromagnetic storms. And these begin to impact us here on the Earth, and it affects communications, it affects navigation. It even has an effect on the humans, as we look at the effect of sun on skin and other things like that. So this electromagnetic radiation is one of the things that affects our systems like that. And and it also begins to help us affect how we see other things happening around us. I mean, since we are seeing communications beginning to be disrupted in some parts of the world, some of the ways that's being done is with approaches that use some of the same type of techniques as what we see from the sun being used there. Also, one of the other questions is does the sun have a surface? And the surface of the sun is not like the surface of our planets. It is really more of a system where it's called the photosphere. And it means, the word photosphere means a light sphere, which is where we get most of the visible light coming into the Earth. And even though we call it a surface, the photosphere is actually the first layer of the solar atmosphere. And it's about 250 miles thick as you begin to look at. So it's not a surface as we know of it here at all. But I was just trying to look at the others. We've already it's already been answered, does the sun affect our climate? And several folks have begun to address the key areas of solar research. I think the other key area of solar research is, again, in the area of medical science, because we know that the length of the day affects our health, affects our moods. We know that the sun radiation affects our skin and our body. And we're just now beginning to understand some of the other parts of the sun's radiation and the light that we get from it and the vitamin D we get from the sunlight and things like that. So there's uh, research in science around the sun, research in space, particularly space weather, as Edward talked about, and even how does it affect our moods and our bodies. So a lot of research going on in those areas too. Um, I think most of the questions in the comment section have been answered, Sharif, so I hope that helped. But
Thank,
I agree with what Edward said. You always pick the best topics. And I almost want to see where the algorithm is that chooses your topics and lets you begin to shape them. Because there has to be some type of data science involved with that.
thank you, Professor. Thank you, Professor. Professor Ting.
Well, this every about 350 years, there's going to be a big solar wind which will wipe out all the communications on Earth, which is as serious as earthquake, as a volcanic explosion, eruption. So this people are tracking this. I guess they're doing a good job. And also another point about funding of energy is it we're changing matter into energy. Okay, there's only so much and heat the Earth can take. So you count solar energy, it does not increase the total energy. Okay, but nuclear, fossil fuel, they change matter into energy. So people need to track of this and inform the public of this data. How much, with fuzzy logic, you have to have a range of tolerance of the Earth, of the total heat. Okay, I'm pushing fuzzy logic as the new foundation for knowledge. I say that the exact logic is without range of tolerance. This is not reality. Reality is fuzzy. Okay, so basically, we like to introduce fuzzy logic into this whole discussion. And also, I'm a technical person, so I would say, my generalized fluid description is based on generalized phase space. Phase space, only plasma physics is really familiar with phase space because it's used in kinetic theory. But now I have a generalized phase space. In other words, you can go into acceleration dimensions instead of just position and velocity. So, I ask a sheriff to double hit. In order to double hit, you have to have the racket and the ball have the same position, same velocity, same acceleration. Okay. In kinetic theory, you only have a same velocity and position, so the particle will move together. But if they accelerate, you need to consider acceleration, which causes the drift instability. So this acceleration consideration is important. You study the sun. Sun is a big plasma. You see, and lots of lot of cosmic entities. They are plasmas. So the plasma physics foundation is not there, and I'd like to get people to look into it. And also all this project, they should consider value theory. And nobody so far accept the value theory of Gerald de Brue, Kenneth Arrow. And I actually solved the problem for real estate and for stock. Stock need a double iteration, so we calculate the rate of return. For real estate, I calculate the price. So basically, people, there's things. It's right now we're living a money-oriented society. So knowledge, I think it is a big vacuum in knowledge. So fundamentally, it's the problem with knowledge. That's all. Yeah. Okay. So
Well, it looks kind of like Sharif is frozen right now. Paul, do you
Yeah,
want to pick back up the comments?
yeah. I think Sharif is frozen. So let me address the idea of the connection of the sun to communication systems, because well, the sun, like I said earlier, has a strong magnetic field like that of the Earth, and so there's charged particles that can it extends all the way, of course, to the Earth, and we call these things the Van Allen belts, if you like, and you can think of a line of electric magnetic field, and any charged particles kind of they circle around the magnetic field and they track it. So when they're impinging on the northern hemisphere in the winters, these charged particles or plasma um, can ionize atoms in the atmosphere and cause these beautiful aurora borealis displays. So that's a direct result of the charged particles coming from the sun. But the anytime, of course, most communication systems, whether it be radio waves or light pulses going through fiber optic cable, or electrons going through copper, though it's all electromagnetic radiation, and anything that interferes with that um, process can cause problems. So the massive solar storms that happen every 350 years or so can really knock out, fry, most electronic systems on our planet. And the military has talked about and developed in the past, sort of neutron bombs and things that would cause a huge electromagnetic pulse to wipe out silicon-based circuits. And these pulses don't have as much effect on older electronics, which was the tubes that were used before the electronic the silicon transistors were developed in about the late 40s after the war. So our whole system is at risk. There was a mild solar disturbance. I don't know, 3, 4 decades ago. I don't remember the date exactly, but some of the power grid in Quebec was knocked out temporarily by this disturbance. And if you go back to the late 1800s, I think there was a large event then, which what would have wiped out electronics, but of course the electronics didn't exist back then. So this is a risk, which is like many other risks. Is um, we don't evaluate or assess risk very well when they're a low probability event with a high impact. Because if you look at the risk, that's the probability of something happening times the impact or the consequences. That's the risk to us. And things that are very low probability, very, very tiny numbers of probability times a very, very large impact can give you a significantly large number, but we're much better at assessing risks that are much more likely to occur with much lower impacts. Those we do a bit better, but we're still not great at that. So the also, you may notice when you're on a car trip, you're driving out on a car trip in the country, and at night sometimes you can pick up on your AM radio stations that are hundreds and hundreds of miles away that you would never be able to pick up on your radio during the daytime. And the reason is, of course, is because of the sun interacting with the atmosphere. So during the daytime, the atmosphere is heating, of course, and there's a band of plasma up high in the high atmosphere, which, as the Earth is expanding because of the heating, that band of plasma high in the atmosphere goes further away from the Earth, and that band reflects radio waves. So the radio waves they can go up quite high and then reflect back down, but they don't go across the surface of the Earth that far. Of course, at night, when the atmosphere cools, that plasma band moves down with the atmosphere kind of shrinks compared to the daytime um, situation, and that band of plasma moves closer to the Earth. So the radio wave that moves up and bounces and hits it can actually travel along the surface of the Earth much further. So AM stations have great. You can get AM stations hundreds of miles away at night, whereas during the daytime they have to be much closer. So that's again another effect of the interaction of solar of sunlight on the Earth. And of course, the wavelength of the sunlight coming to the Earth depends on the temperature. We call it, there's a whole theory of black body radiation, and the Earth, the sun is what 6,000-7,000 degrees black body. So it puts out radiation of a certain spectrum. It's all calculated from the physics, and the visible light can easily penetrate the atmosphere. But then the Earth acts as a black body with a temperature of that 255 degrees or 270, 298 degrees rather, which is the surface. But then if it's a black body radiator, you have to take it up in the atmosphere. But anyway, because of that much lower temperature of the Earth than the sun, the radiation the Earth emits, the spectrum is in the infrared for the most part, and this is where the atmosphere comes in and absorbs a lot of that and keeps the surface of the Earth much warmer than it would be without an atmosphere. But because we're changing the chemistry of the atmosphere, we're changing the amount of infrared absorbers in the CO2, the methane, the water vapor, etc. Then we have this global warming issue. So any other exoplanet out there is very likely to experience the same sort of thing as we have on Earth. And this leaves some very interesting questions about is there life on other planets, and if there is life on other planets, would we be able to communicate with it and find out that it's there? What level of advancement would it have? And there's some sort of equation called the Drake equation, which gives you sort of the probability of another similar planet with life, and you do all the numbers, and the question then becomes can an advanced civilization like ours have any sustainability, or do we self-destruct, right? And this is a question, because if there are other planets that support life and civilizations develop, there may be a very limited time compared to the long time scales of the universe, etc., for that advanced life to exist before it kind of self-annihilates. So these are all very important existential questions that we're asking ourselves now, as we face all of these limits to life on Earth. So
Thank you, Professor Paul, for your excellent analysis. Now I directly want to go for the concluding remarks. Tomorrow we have our debate. So those who want to join in the debate, you can join. Professor David Smith, tomorrow we have debate. So naturally, Professor Rob has one team, you has one team. So you want to go for government or opposition?
What's the topic?
Topic, just a minute. This house believe that I think topic based on robot, but I need to confirm it again. Okay, this house believe that robot is going to increase of quality of life.
Well, that may be the government.
Okay, okay. So Professor Rob will be opposition. So Professor Paul, Professor Ching, if you want to join in the debate, you can join. Debate is very popular because we are also organizing, getting invitation for Aaron's different debate, and especially our youth, our young community, they like to observe the debate. So I want to invite you all, our audience, for joining tomorrow's debate. Uh, Professor David, what's your concluding remarks for today?
Well, Sharif, thank you for this topic again. It has been more wide-ranging than I thought when I first saw the topic, and that's been very good. The questions have been very good too, and it really struck me as I was thinking about this as we began with the differences of scale and the impact. The sun and the life of the sun affects all of us, and it affects us from when we're born through everything we tend to do. And it's a constant that we take for granted. And even though we're in the midst of its life cycle, and it's a very long life cycle, it's still, we take it for granted. And it's so important that without it, life wouldn't exist. And it's that level and how it affects our climate, how it affects our bodies, how it affects our communications, and everything we do is just so vitally important. And we are beginning to know more and more about it. We've had the first spacecraft go within, 23 million miles of the sun. And that's the closest as we've gone. So we will see how it continues to evolve, how our science advances, and see if we can tame the process of the sun to help us solve climate change as well. So Sharif, thank you so much for letting me be part of this.
Thank you, Professor David Smith. Professor Ching, what's your concluding remarks for today?
Okay. Well, this discussion about the sun is a problem of survival. Okay, I think this we're getting to the main problems for humanity, for human on Earth. So this for survival is the ultimate. It's so difficult. It's unlimited. Therefore, we definitely need this field, a new field of knowledge of fuzzy logic. Okay, we can never solve it exactly, but we want to push the limit of the solution. You see, I'm doing this problem on touch. Tomorrow robotics, touch should define whether an intelligent machine is a robot or not a robot. A robot cannot interact with its environment. It's not a robot. It's an intelligent machine. Okay, so this problem of touch is heavily dependent on this fuzzy logic. Also, this problem of sun. See, it's a very fragile system. The solar system is a very fragile system. If you think about it, we're all spinning, we're around. What is going on? Anything can happen, instantly, and they just wipe everything out. So I'm for studying astronomy, a solar system. There should be more funding, but we need to use value theory to determine their priorities, not just randomly do whatever interests us. And the society needs a lot of things to advance, and I outline all this advancement in a paper called the cultural level quotient. It's like intelligent quotient. It's a cultural level quotient. Okay, you search it's a paper which says the cultural level depends on method of reasoning. Okay, today we only got to empirical reasoning based on empirical data. But in social science, we would reason based on mathematical rigor, complete mathematical rigor. In life science, we have to reason by complete logical rigor because life deals with DNA, which is a logical machine, just like a computer. And all this is not fuzzy. These are exact what I just mentioned. You see, once you go into fuzzy logic, it elevates all the culture to another level. So basically, the current society, promoted by my friend Milton Friedman is in the middle of the money-oriented society. Anything that make money is the key. But our group say that only knowledge is of value. You see, and also our group also invented money. hope people will come and take a look at that. Okay, so basically, my position, I hope this discussion will get us the most intelligent people, young people, old people, whoever, if they can understand some of the things we talk about. I can publish paper easily. I just anything I send in, the editors who admire me, they just willing to publish. As for especially for young students, they publish few papers. They are a step ahead of the rest of their peers. So basically, I hope our discussion can get into more serious. Definitely, I'm be on the side of robot in a debate. Okay, because we have a totally different view from current society. Okay, the society does not understand what is going on. Okay, they don't even know what is the definition of robot. Okay, and they keep talking about they do everything in science, but that is not the right way. Okay, anyway, this is very very interesting. I learned a lot from Paul and from everybody else. Yeah.
Thank you. Professor Paul, what's your concluding remarks?
Yes. Thank you for doing this session, Sharif. And like the others, when I first heard of the topic, I thought, oh, the sun. Well, what can we talk about? But there's obviously lots. I mean, the sun is essentially the center of life. I mean, without sunlight, there's no life. And the plants, of course, use sunlight and have evolved these incredible chemical reactions to use the sunlight as energy to create the building blocks to build up the carbon molecules and build up the build up plants, which of course are vital for then animals came along, and the plants of course produce the oxygen, which brought the oxygen levels up on Earth to about that 19-20% level or so. The sun's vital, for us, for animals. I mean, some of the sunlight reacting with our skin, it generates vitamin D, and we're very spiritually connected to the sun. Who doesn't love sunsets and sunrises? Who goes to a beach and doesn't watch the sunset and sunrises? The sunsets are the days, it sets day and night, it sets we base our schedules of all human activity on day and night. When you think about it, without the sun, what would our schedules be based on? Of course, as well as being the center of our solar system, the sun is responsible for all energy on the surface of the earth. The sun causes uneven heating on the earth and in the atmosphere, and that generates winds. So wind turbines are actually really a form of solar energy, and we can make devices, photovoltaic cells, etc., to actually absorb sunlight and create electrons. So or we can use different types of solar collectors. We can focus the solar energy onto water tanks and create steam to drive turbines. Okay, so this is another form of solar energy, not just photovoltaic, but solar thermal. Solar, I've already talked about the sun creating the elements, right? It's the element generator, and then by changing the reactions in some of these elements, like uranium, we get our nuclear energy. The sun causes the whole hydrological cycle to occur on the earth, where water is heated up and evaporated, rises up, condenses into clouds, causes rainfall. Rainfall on the ground generates rivers, and we can use some of the water movement on these rivers for hydroelectric power. So hydroelectric power is really also solar energy in another form. The sun bakes the, it allows for the plant life to grow, and then when the plants die and become part of the soils and part of the ground and get very deeply buried under the ground, also the animals that die They decompose deep in the ground with the high pressures and create the oil and gas. So oil and gas is really solar energy as well. And as humans have developed civilizations, etc., we part of our sort of spiritual nature and connection with the sun has meant humanity developing things like Stonehenge, I'm thinking of. Okay, so the orientation of the buildings and the rocks that are positioned are done so in such a way that at certain times of the year the sun shines between different rocks and it marks sort of like a calendar to mark the passing of time, so those sort of things. And you can find these sort of things like Stonehenge all around the world, and it sort of brings up the term of sun worshippers. So in a way, every human being is connected to the sun, and you can call us all sun worshippers if you like.
Thank you everyone for joining today's session. Today's session is really helpful, and I told you, like, I can remember my professor, Professor Dr. Habibur Rahman. He died few years ago, but in the first class he always like inspired me. That he said that if you want to be really knowledgeable, you have to know about sun, star, galaxy. That will help you. So yes, my life, my father also. He died. He also one of the great scholars and lawyers. Even he was a politician. He died. Many people in the COVID-19 situation, we actually died in the developing nations. Same thing happened in the developed world. But your knowledge, your contribution for the humanity, it will be valuable for us. So that's why I want to give special thanks for today's sessions to all of our Professor David Speed, Professor Ching, Professor Paul for joining today's session. That is our objective actually. Talent economy, we want to develop our own university, own ecosystem. We are working, we are contributing. But as a team, we can change the world with our knowledge, with our dialogue, with our research. So thank you everyone for your excellent contribution. Tomorrow we have our debate from our speaker. Those who want to join in the debate, you can join. I believe it's become very popular in the global arena. And thank you for today's sessions. Thank you. Bye bye and take care.